You know, every single time you click an icon, open a file, or even just switch browser tabs, you're kicking off this incredible hidden performance inside your computer. It's this whole symphony of signals and data. But who's the conductor holding it all together? Well, in this explainer, we're going to pull back the curtain on the real maestro in the machine, your operating system. Okay, let's get into it.
So our journey starts with that first simple click. What's actually happening when you launch an app? It turns out the OS has to perform this kind of digital alchemy, transforming a totally lifeless program into something that's active and dynamic.
And this right here is the absolute key difference. Think of a program like, well, it's the sheet music for a song. It's just a set of instructions sitting there passively on your hard drive. But a process? That's the orchestra actually playing the music. It's the program in action, using memory, grabbing files, and doing real work.
And this is a perfect example of how it's not a simple one-to-one thing. I mean, when you open 2 Word documents or 10 browser tabs, the OS actually creates and manages a totally separate process for each one. So all of a sudden, you don't just have one orchestra, you've got a whole bunch of them, all wanting to play at once. So how in the world does the OS manage all that potential chaos? Well, that's its next big challenge.
With all these processes screaming for attention, the operating system has to become this master juggler. It's got to decide which process gets to use the computer's brain, the central processing unit, or CPU, and just as importantly, for how long.
I mean, this is the question the OS has to answer, literally every single millisecond. If it gets this wrong, your computer feels sluggish, videos start to stutter, and everything just grinds to a halt. It's not chaos, though. It's a very highly controlled system called scheduling.
Now, what's really cool is how the OS handles this problem. You see, modern systems use what's called preemptive scheduling, and that's the secret to making your computer feel so responsive. Instead of just letting one task run until it feels like it's finished, the OS can actually interrupt it. It can just jump in and say, hey, your turn is up, and give the CPU to another process. This constant, super fast switching is exactly why you can move your mouse so smoothly even while a massive file is downloading in the background.
And the OS isn't just juggling things at random. It's constantly trying to solve this really complex puzzle. It wants to maximize throughput, that's the sheer number of jobs it can finish, while minimizing the time you have to wait around. It's balancing the total time a task takes against how long it's stuck in line, and maybe most importantly for us, it's working to minimize the time until you see that first response on your screen. It's an unbelievably delicate balancing act.
Okay, so our process has been brought to life and it's getting its fair share of time on the CPU. But a process is pretty useless without its data, right? So now the OS has to put on another hat, the hat of a highly organized digital librarian, in charge of the entire file system.
Just think about it for a second. Your hard drive has billions, maybe even trillions of bits of data on it. So when your process asks for document.pdf, how on earth does the OS find the exact correct bits that make up that specific file? It seems like a massive, impossible search problem.
Well, here's the secret. The OS doesn't search aimlessly at all. It uses a map, a special index, kind of like the one you see here, called a master file table, or MFT. Just think of the MFT as the library's main card catalog. When you ask for a file, the OS looks it up in there first. Now, the MFT doesn't hold the file itself, but it has pointers, which are basically just directions, that tell the OS exactly which physical spots on the drive hold the different pieces of your file.
And of course, there isn't just one way to be a librarian. This table gives you a quick look at how different file systems have evolved. You can see how the core index structure, the way the system organizes its map, changed from a pretty simple linked list in older systems to more complex and way more efficient tree structures in modern ones. They also use different tricks for tracking free space, like a bitmap, which is just a map of all the used and unused spots on the drive. Every new version is all about getting faster and more reliable at finding your data in an instant.
So, we've seen the OS as an alchemist, a juggler, and a librarian. Let's bring all these pieces back together and take a look at the full performance conducted by your amazing operating system.
So this is it. This is the incredible journey of every single click. First, a dormant program is awakened into an active process. Then, the scheduler juggles dozens of other processes to give yours a slice of CPU time. And finally, the file system acts like a lightning-fast librarian to instantly retrieve the exact data that process needs. And it all happens seamlessly in the blink of an eye. At the end of the day, this quote just nails the whole point of the OS. Its job is to create simplicity out of absolute chaos. It gives us a simple idea, what we call an abstraction, like a file or a folder, but behind that elegant simplicity is a staggering amount of complex work to manage the raw hardware. The OS is the ultimate translator between what we want to do and what the machine physically has to do to make it happen.
And the really crazy part is, it does all of this with incredible reliability. This complex dance happens billions of times a day on your machine, almost flawlessly. Which kind of leaves us with one last thought. After all this brilliant, intricate design, what are the things that can still bring this perfectly conducted symphony to a crashing, grinding halt? Well, that's a story for another time.